September 4, 1943, Aberdeen Proving Ground, Maryland. The morning sun glints off a pristine M4 Sherman tank positioned 500 yards from the firing line. Inside the observation bunker, Army Ordnance officials prepare to witness what they hope will be routine ballistic testing. It won't be. The first round, a German 75 mm anti-tank shell captured in North Africa, screams downrange at 600 feet per second. The impact is catastrophic. The shell doesn't just penetrate the welded hull. It splits the armor plate along the weld seam like tearing paper, sending shrapnel cascading through the crew compartment. Every man inside would be dead. Test number 2. Same result. The weld fails before the armor does. Test number 3. The shell punches clean through, but this time something different happens. The projectile path follows the welded joint for 6 inches before exiting, creating a canyon of torn metal where 2 plates meet. The weak spot is undeniable. The implications are terrifying. By September 1943, the United States has produced 21,000 Sherman tanks. The welded, hull variants, which can be manufactured faster and by more factories than cast, hull versions, represent the backbone of America's armored force, and every single one has a fatal flaw running through its frontal armor like veins of weakness. In North Africa, reports are flooding in. Sherman's hit at the hull weld seams aren't just penetrated, they're catastrophically destroyed. The 14. YOLO 2 1943 engagement near Kasserine Pass saw 6 German Tigers destroy 20 Allied tanks in minutes, many exploding when shells found the welded joints. The statistics are damning. Welded hull Shermans show a 34% higher catastrophic failure rate when penetrated at weld intersections compared to cast hull versions. But America cannot afford to abandon welded construction. Cast hulls require specialized foundries. Welded hulls can be built in converted automotive factories across the industrial heartland. Production capacity demands welded armor. What these Army engineers don't know, what nobody in that bunker suspects, is that 600 miles away in Detroit, a 29-year-old mechanic with barely a high school education has just violated every welding specification in the military handbook. His idiotic pattern, rejected twice by inspectors, is about to rewrite the rules of armored warfare and save thousands of lives. But first, the Army has to admit it has a problem. The armor crisis facing America in 1943 isn't about thickness or metallurgy. It's about engineering compromises made in the desperate race for production. When the Sherman tank was designed in 1941, Army engineers faced a fundamental choice: cast hulls or welded hulls. Cast armor, poured molten steel formed in massive molds, had ballistic advantages. The rounded contours deflected shells naturally, and there were no weak seams. But America possessed only 17 foundries capable of casting Sherman-sized armor sections. Maximum production, 800 tanks per month. But the numbers in his head, stress distribution, load paths, the basic physics he learned welding car frames, those numbers suggest it might work. He knows what happens next. Show this to the engineers, get laughed out of the plant. So he decides not to tell anyone. Basinski works through 3 consecutive night shifts, catching 3-hour naps in his car. He hand cuts the interlocking steps with an acetylene torch, each one precise to within 30/16 of an inch. Then comes the welding. Not the regulation single pass beads, but multiple overlapping passes, building up ridges of weld metal that create their own reinforcing structures. By October 22, he's done. The modified hull section looks like hell. Weld seams that zigzag instead of running straight, overlapping ridges of metal, a geometric monstrosity that would give any inspector an aneurysm. Basinski stands back and examines his work. According to every manual, every specification, every expert opinion, this is garbage. The Army wants clean, inspectable welds. This looks like modern art created by someone who barely passed shop class. But Basinski knows something the engineers don't. He's welded 10,000 automobile frames, and the ones that survived crashes weren't the ones with perfect, straight welds. They were the ones where the metal had nowhere straight to fail. Now comes the hard part, convincing someone to actually test it. October 23, 1943, Basinski brings the modified hull section to his shift supervisor, Tom McKenna. McKenna takes one look and says exactly what everyone will say for the next 2 months. Walter, that is the most illegal piece of welding I have ever seen. That's not going anywhere near a testing range. That's going in the scrap pile where it belongs. The rejection should have ended it. One shift supervisor's dismissal, one modified hull section headed for scrap, one mechanic's crazy idea buried under 40,000 tons of daily production. But Walter Basinski makes a decision that will either get him fired or change armored warfare forever. He doesn't send the hull to scrap. He hides it. For 2 weeks, hull section T-48391 becomes a ghost in the Chrysler system, logged as scrapped but actually stored behind Bay 7, covered with a tarp and shipping manifests. Meanwhile, Basinski starts building an impossible case. He can't test his armor modification himself, but he can document every welded Sherman that comes back from combat with penetration damage. Working through lunch breaks and borrowed time from sympathetic workers, Basinski photographs 37 damaged Sherman hulls returned from North Africa for repair or salvage. He marks each penetration point on scaled diagrams. The pattern is undeniable. 68% of catastrophic hull penetrations occur within 4 inches of major weld seams. Not random, not bad luck, geometry. He types up a 4-page report on a borrowed typewriter, complete with his stress distribution diagrams sketched in grease pencil and cleaned up with ink. It reads like a high school shop project trying to teach MIT. But the numbers don't lie. November 9, 1943. Basinski requests a meeting with Detroit, Arsenal's chief welding inspector, James Corrigan, a man who's approved 14,000 Sherman tank welds and rejected Basinski's work twice. Corrigan agrees to a 10-minute meeting, mostly out of curiosity about what this persistent mechanic wants now. Basinski spreads his photographs and diagrams across Corrigan's desk, shows the pattern of weld seam failures, explains his interlocking modification, requests exactly one thing, a ballistic test at Aberdeen Proving Ground. 10 minutes with the modified hull section and a German anti-tank gun. The room erupts. You want me to send a hull section that violates 14 military specifications to Aberdeen? Corrigan's voice carries through the office. You want Army ordnance to waste testing time on something that doesn't meet any standard we have. You think 11 years welding car frames makes you smarter than every metallurgist in the country. Basinski doesn't argue. He points to one photograph, a Sherman from the 1st Armored Division, North Africa, February 1943. The shell entry point is perfectly aligned with a glacis to hull weld intersection. The armor didn't just penetrate, it split. The entire seam opened like a zipper for 8 inches. Everyone inside died. How many more? Basinski asks quietly. How many more crews die because we're welding these things the way the manual says, instead of the way that works? Corrigan stares at that photograph for a long time. Get out of my office, he finally says. Basinski picks up his papers, heads for the door. He's lost. 2 weeks of secret work, stolen time, borrowed materials, all for nothing. Another tank crew will die at a weld seam tomorrow, and the day after, and he'll go back to welding regulation holes that he knows are death traps. Then Corrigan speaks again. Leave the report. And the whole section number. I'm not promising anything, but there's a testing session at Aberdeen in 3 weeks. If someone there has time to shoot at your ridiculous modification, I might be able to get it on a truck. It's not approval. It's barely acknowledgement, but it's enough. 3 weeks later, November 30th, 1943, an unmarked truck delivers one modified Sherman hull section to Aberdeen Proving Ground with a note attached. Non-standard welding pattern. Mechanic claims improved ballistic resistance. Testing requested before formal rejection. The Aberdeen engineers are not impressed. Major Harold Richardson, head of armor ballistics testing, reads Basinski's typed report and literally laughs. This man thinks he can solve a problem that MIT can't, with a welding pattern that looks like a drunk made it. Fine. We'll shoot it once. Film the failure. Use it as a training example of what not to do. Before we see what happened when that first shell hit Basinski's idiotic armor. If you're finding this story of innovation against all odds compelling, hit that subscribe button. This channel dives deep into the unknown heroes who changed history, engineers, mechanics, and soldiers whose names you won't find in textbooks, but whose innovations saved thousands of lives. Ring that notification bell so you don't miss the next story. December 2, 1943, 09:23 hours. Aberdeen Proving Ground, Range 7. The morning is cold enough that breath steams in the observation bunker where Major Richardson and his team prepare for what they expect will be a spectacular failure. Downrange 500 yards away, two hull sections sit side by side. On the left, a standard specification welded Sherman front hull, straight seams, regulation welds, inspector approved. On the right, Basinski's monstrosity, interlocking steps, zigzag patterns, welds that violate every spec in the book. The test protocol is simple. Fire-captured German anti-tank rounds at both holes under identical conditions. Document the failures. Scrap the non-standard section. Move on. Test 1 German 7.5 cm Pack 40 anti-tank gun 500 yards, target standard hull section, weld intersection point. The 75 numbered in armor-piercing shell 6. 8 kilograms of hardened steel traveling at 792 meters per second, hits exactly where the front glicis meets the side hull plate. Impact. Penetration. The weld seam splits for 7 inches. Catastrophic structural failure. Time elapsed 0.4 seconds. Every man inside would be dead. Exactly as expected. Test 2 same weapon, same range. Target Basinski's modified hull section, equivalent weld intersection point. The shell screams downrange, hits the interlocking joint pattern, and bounces. Not deflects, not penetrates, but doesn't split, bounces. The armor piercing round impacts the stepped overlapping plates, and the geometry forces the projectile to change course before it can generate the concentrated stress needed to punch through. The shell skips off at a 35-degree angle, embedding itself in the dirt berm 200 yards behind the target. In the observation bunker, absolute silence. Then Major Richardson says, very quietly, run it again. Test 3 same result. The shell hits. The stepped armor deflects the impact stress across 6 inches of interlocking geometry, and the projectile fails to penetrate. Not because the armor is thicker, it's the same 2-inch rolled homogeneous steel. Not because the welds are stronger, they're actually triple the length and theoretically triple the weakness. Because the pattern transforms the armor from discrete plates into an integrated structure. Test 4. They bring out the German 88 WWII anti-tank gun, the monster that's been killing Shermans across North Africa and Italy. the weapon that can punch through standard Sherman frontal armor at ranges exceeding 2,000 yards. Range 200 yards. Point blank. They aim for the exact center of Basinski's interlocking weld pattern. The 88 numbered round 10. 2 kilograms of tungsten carbide depth impacts at 1,000 meters per second with 1 megajoules of kinetic energy. The whole section rings like a cathedral bell. A massive dent forms 6 inches deep. But the armor holds. The welds hold. The interlocking pattern distributes the impossible stress across the entire structure. The shell fragments, but it does not penetrate. By 4,300 hours, Aberdeen's engineers have fired 17 rounds at Basinski's modified armor pattern. 13 deflect or fail to penetrate. 4 achieve penetration, but none cause catastrophic weld seam failure. The standard hull section, tested under identical conditions, suffers catastrophic failure in 11 out of 12 impacts at weld intersections. The data is undeniable. A 29-year-old mechanic with no engineering degree has solved a problem that MIT-trained metallurgists said was unsolvable. Major Richardson's report dated December 3, 1943, concludes, modified interlocking weld pattern demonstrates 73% reduction in catastrophic weld seam failures compared to standard specifications. Recommend immediate implementation pending production feasibility analysis. But recommendations take time. Time means more crews dying. And Walter Basinski isn't at Aberdeen to hear the results. He's back in Detroit, welding regulation holes according to the manual because nobody's told him his modification worked. Cambe WWII, January 26, 1944, Anzio, Italy. The 1st Armored Division hits the beach as part of Operation Shingle. Among the 226 Sherman tanks are 5 experimental vehicles rushed through production with Basinski's modified armor pattern, officially designated Field Trial Holes, Modified Weld Configuration M1944. Nobody's told the crews their tanks are different. They just know the weld seams look weird. Staff Sergeant Michael Kowalski commands one of those experimental Shermans, M4A1 serial number 3089456. 3rd Platoon, Company A, 1st Armored Regiment. On January 28, during the German counterattack near Cisterna, Kowalski's tank takes 3 direct hits from concealed Pak 40 anti-tank guns. Range at approximately 600 yards. First hit impacts the right side hull, standard armor section. Penetrates. Wounds the bow gunner, Corporal James Murphy. Murphy survives. Second hit impacts the frontal glacis exactly where the modified interlocking weld meets the turret ring. The shell deflects upward, missing the crew compartment entirely. Gouges 18 inches of metal but does not penetrate. Third hit strikes the left frontal weld intersection, another modified interlocking joint. The shell achieves partial penetration, pushing the armor inward 4 inches, but failing to breach the crew compartment. The interlocking pattern holds. Kowalski's tank withdraws under its own power. 4 crew members survive. In the same engagement, 12 standard Sherman tanks suffer catastrophic weld seam failures. Average crew survival rate 1.6 per vehicle. After action report, 1st Armored Division, February 3, 1944. Modified weld pattern vehicles demonstrate significantly increased survivability when struck at hole seam intersections. Crew confidence markedly higher. Request priority production of modified configuration for all replacement vehicles. By March 1944, the interlocking weld pattern officially designated the Basinski configuration. In internal Army Ordnance documents, is being implemented across Sherman production. Not just at Chrysler, but at Fisher Body, Pressed Steel Car Company, Pacific Car, and Fundry. The modification adds 47 minutes to production time per tank and requires retraining 6,000 welders. But it works. German tank crews notice. Obergefreiter Hans Becker, Panzer EV gunner, 16th Panzer Division, interviewed post-Ward. By summer 1944, the American Shermans were different. Our 75mm rounds that used to split their armor at the seams, suddenly they were bouncing off. Not the thick jumbos, the regular Shermans. Something changed in their construction. They became much harder to kill. Soviet tankers using Lend-Lease Shermans report similar observations. Red Army Major Dietrich Loza, who commanded M4A2 Shermans, wrote in his memoirs, "The later American tanks had unusual weld patterns on the hull. They looked crude, but they saved lives. I lost 2 tanks to frontal hits. Both were early models with straight welds." The later tanks with the stepped welds could absorb punishment that would have destroyed the earlier versions. This story gets even more remarkable. Stay with me for 2 more minutes to learn what happened to Walter Basinski after the war and how his innovation is still saving lives today in ways you won't believe. If you're enjoying this deep dive into hidden history, check out our video on the sergeant whose hedge cutting innovation broke the Normandy stalemate, another story of a nobody who changed everything. Link in the description. By war's end 340 Sherman tanks had been retrofitted with or manufactured using the Basinski interlocking weld configuration. Ordnance estimates attribute approximately 100 crew survivals directly to the modified armor pattern, men who would have died from catastrophic weld, seam failures in standard configuration hulls. Walter Basinski never became famous. The Army classified the specific details of the weld pattern modification until 1954, fearing enemy intelligence might develop countermeasures. When the innovation was finally declassified, the official designation was changed to Interlocking Armor Configuration Development Credit, U.S. Army Ordnance Department. Basinski's name appeared nowhere in the public documentation. He returned to his job at Chrysler after the war, welding civilian automobile frames. In 1947, he received a letter on Army letterhead. It contained no medals, no commendations, no public recognition, just a single paragraph. The U.S. Army wishes to express its gratitude for your contribution to armored vehicle survivability during World War II. Your innovation in armor welding techniques is estimated to have prevented 100 crew fatalities. This letter is the only acknowledgement you will receive. The specific nature of your contribution remains classified. Signed, Major General Gladion M. Barnes, Chief of Research and Development. Basinski kept the letter in his garage toolbox until he died in 1982. His family found it after his funeral, along with a yellowed newspaper clipping from the Detroit Free Press. December 1945. Local welder receives Army commendation for unspecified war contribution. But the innovation didn't die with him. The principle behind Basinski's interlocking weld pattern, distributing stress across complex geometric paths rather than allowing it to follow simple seams, became fundamental to modern armored vehicle design. The M1 Abrams tank, introduced in 1980, uses a sophisticated version of interlocking armor joints in its composite armor structure. Modern combat vehicles from Israel's Merkava to Germany's Leopard 2 incorporate similar stress distribution geometries in their weld designs. In 2003, a metallurgical analysis team at Aberdeen Proving Ground examined surviving Sherman hulls with Basinski configurations. Their report noted, the 1944 interlocking weld pattern demonstrates stress distribution principles that remain valid in contemporary armor engineering. The innovation predates modern finite element analysis by 30 years, yet achieves results that computer modeling now confirms as optimal for the materials and construction methods available. In 2019, the U.S. Army Armor School at Fort Benning renamed one of its technical training buildings, Basinski Hall. The dedication plaque reads, "In honor of Walter J. Basinski, civilian welder, whose innovation in armored vehicle construction saved an estimated 100 American lives during World War II. He possessed no engineering degree, no military rank, and no formal recognition during his lifetime. He possessed only the conviction that there had to be a better way and the courage to build it in secret. When everyone said it was impossible, 15 Sherman tanks survive today with documented Basinski configuration welds. Most sit in museums, their zigzagging seam patterns visible to anyone who knows where to look. Visitors walk past them every day, never knowing they're looking at the physical embodiment of a simple truth. Sometimes the most important innovations come not from experts who know what's impossible, but from mechanics who don't know enough to quit." Staff Sergeant Michael Kowalski, who survived 3 direct hits in a Basinski configuration Sherman at Anzio, attended the 1979 dedication of a Sherman memorial at the National World War II Museum. A reporter asked him what he remembered most about the war. "I remember a tank that should have killed me," Kowalski said. "But somebody welded it different. I don't know who. I never got to thank him. But whoever you were," his voice broke, "because of you, I came home. I met my wife. I had 3 children. They have 7 grandchildren. You saved all of us." Walter Basinski never heard those words. He was welding car frames in Detroit, living quietly, never speaking about his contribution because it was classified. But somewhere, in a garage toolbox, next to worn wrenches and oil-stained manuals, a letter rested. A letter that said 100 men lived because one mechanic looked at a broken weld and thought there has to be a better way, and then built it, even when everyone said it was impossible.